Hello friends, welcome back to my channel. In this video, I am going to solve exercise question from book Topics in Algebra from chapter Vector Spaces and Modules. So question is, if U and W are subspaces of a vector space V, prove that U plus W, which is set of all those vectors V in vector space V, such that V can be written as sum of the vectors U plus W, where U is vector from subspace U and W is a vector from subspace W, is a subspace of V. Before proving this result, firstly we will recall some important concepts which we are going to use in our proof. So first one is the concept of subspace of a vector space. So let V over field F is a vector space and W is any subset of V, then W is a subspace of V if under the operations of V, W over field F is itself becomes a vector space. Next, we have a theorem which states that let V over F is a vector space and W is any subset of V, then W is a subspace of V if and only if number 1, 0 vector is a vector in set W, and number 2, for all vectors say W1, W2 in set W, and for all scalars say alpha beta in field F, we have the linear combination alpha W1 plus beta W2 is some vector in set W. Now we are ready to prove the given result. So proof, here U and W are subspaces of vector space V and set U plus W is collection of all vector V in vector space V such that V is equal to U plus W, where U belongs to U and W belongs to W. Now note that number 1, since both U and W are subspaces of vector space V, we have from definition of a subspace, 0 vector will be vector in both U and W. Now 0 can be written as 0 plus 0, so this 0 becomes the member of set U plus W. Number 2, let V1 and V2 are any two vectors in set U plus W. Then from definition of set U plus W, we have V1 is equal to U1 plus W1 and V2 is equal to U2 plus W2, where this U1, U2 are vectors in subspace U and W1, W2 are vectors in subspace W. Then for scalars alpha beta in field F, we have the linear combination alpha V1 plus beta V2. This can be written as alpha. Now this V1 can be replaced by U1 plus W1 and this V2 can be replaced by U2 plus W2. So we get this step. Now using scalar multiplication, this can be written as alpha U1 plus alpha W1 plus beta U2 plus beta W2. Again, using associativity and commutativity in V with respect to addition, we get, or we can write this as alpha U1 plus beta U2 plus alpha W1 plus beta W2. Now since U and V are subspaces, alpha U1 plus beta U2 will be some U3 vector in subspace U. Similarly, alpha W1 plus beta W2 will be some vector say W3 in subspace W. So we can write this as U3 plus W3. Again, we have alpha V1 plus beta V2 is equal to sum of vector U3 plus W3, where U3 is coming from subspace U and W3 is coming from subspace W. So we get alpha V1 plus beta V2 is equal to some vector say V3, where V3 is equal to U3 plus W3. So by definition, we have the linear combination alpha V1 plus beta V2 is a vector in set U plus W, and therefore by this theorem we get U plus W is a subspace of vector space V, and this proves our result.